I'm getting a few questions about how to convert rectangular coordinates to polar coordinates, so I just wanted to real quick address it in this video. So first thing I would do is always sketch it. So if I have these rectangular coordinates of -1, 1, it's going to go back 1, up 1, so that would terminate here. And what I want to do is I want to figure out both the radius and the theta, right? I want to turn it into polar coordinates. So first off, let's just think about this triangle that's right here. I'll sketch it out here. So this is -1, this is 1, right? X and Y. And then I want to find that radius r. So that's Pythagorean theorem. So -1 squared plus 1 squared equals r squared. So 2 equals r squared, square root of 2. So I know that my r part is square root of 2. And the second part is, how do I find this angle? Now in some cases I can look at the unit circle. Right, like back 1, up 1, back 1, up 1 would be here. And so notice that like this, you could scale this up to -1, 1. So you can just see that it's 135 degrees, or 3 pi over 4. Now it might be that like you don't see it, or it's actually like not even literally on here. So the other thing we can do is we can find this angle here, and then use it. That'll be this angle here, and then use it to figure out what that angle is. And the way that we do that is, well, like think about solving this triangle. That's some angle. I'll just call it A. I know that tangent of A would be y over x, 1 over -1, right? Opposite over adjacent. So one thing that will help me in this always is to know that tangent theta is always y over x, right? And y over x are given to me. Now that's not necessarily going to give you this angle. You have to sketch it to realize like what angle you're going to use. And once I find this angle, in this case I'm going to go 180 minus it. So tangent of 1 over -1, I'm going to grab my calculator, inverse tangent of that, inverse tangent, let me get rid of that, of 1 divided by -1, you could just put in -1 of course, -45 degrees. So notice that it gave me -45. And remember, that's something that something that inverse tangent does. I want inverse tangent of 1 over -1 equals a. That's some inverse tangent only returns values here and here. But what that does tell me is this is 45 degrees right here. So if that's 45 degrees, this would be 180 minus 45. And again, it's that 135, 3 pi over 4. So you could write it this way. It's usually best to write it this way if you can, in radians. And if you can't, you could just say, boom. So notice our answer would not be -45. We have to make some sense of it. I'm going to do another example of this with this point. 6, -8. I'm going to rewrite it down here. Sorry about that quick pan. So first thing I'm going to do is sketch this thing. That'd be over 6 down 8. Again, I'm not drawing it to scale at all. That distance is 6. That distance is -8. And what I want is that, there's my theta, and I also want to know my radius, my r. So let me lift out this triangle. If I lift out that triangle, I can get my my r, my radius, Pythagorean theorem, 6 squared plus 8 squared, and then square root it. It's -8 squared, but it's going to come out as positive. 36 plus 64, square root of 100 is 10. So I know r is 10. Now I need to know theta. I need to figure out that part. Again, I'm going to use inverse tangent. So I'm just going to figure out this angle now, and then once I know that angle, I can figure out that angle. It'll be 360 minus it. And I'm going to do this in degrees because I don't think it's going to be something pretty. So I know that inverse tangent of y over x. Let me grab my calculator and do that. Inverse tangent of -8 divided by 6. And I'm just going to round it. It looks like about -53.1. That's good enough for me. So it's about that. So that's what this angle would be. So my theta would be 180 minus that, which is about 126.9. So it would be 10, and I'm good with 126.9. All right, I hope that helps. Email me if you have questions.